You ever see a tweet or a text and wonder how on earth does a computer understand any of that? I mean, with all our slang and typos and emojis? Well, it's a huge deal in data science, and today we're going to pull back the curtain on the very first, most crucial step, text preprocessing. Let's get into it. Okay, take a look at this. You and I, we get it instantly. It's someone excited about a movie, right? But for a computer, this is just a chaotic mess. The @ sign, the URL, the extra letters in so, it's all basically gibberish. So really, where would a machine even start to pull out the meaning? The simple answer? It can't. Not in this state. The best way to think about it is this. Raw text is like a super messy office. You've got papers piled high, things are totally disorganized, and you can't find anything. That tweet? To a computer, it's that messy office. Before any real work gets done, we have to tidy up. And that really gets us to the heart of the problem. Let's dig in and break down exactly why this kind of text is pure chaos for any algorithm. So what makes it so tough? Well, first, you've got all this noise. The punctuation, the links, the hashtags. They don't really tell you what the person feels, they just get in the way. Then there's the inconsistency. A computer sees run, running, and ran as three completely different things. And when you have tons of unique words, everything gets really complex and slow. But honestly, the biggest problem of all? Computers don't speak English. They speak math. They need numbers to do anything.
So if raw text is our messy office, how do we start cleaning? Well, thankfully there's a whole procedure for this. You could almost call it the art of tidying text.
And this whole tidying up process has an official name. It's called text preprocessing. It's all about that transformation, taking the chaotic, raw stuff and turning it into a clean, organized format that our machine learning models can actually work with. And this quote just hits the nail on the head. It's just like our messy office analogy, right? Once everything is filed away properly, finding what you need is a breeze. That is exactly what we're trying to do here, create order out of all that text chaos.
All right, let's roll up our sleeves and get our hands dirty. The very first step in tidying our messy text office is just getting rid of all the obvious junk.
We're going to start with three main jobs. First, we'll ditch stuff like website links and user handles. They don't really add to the message. Next, we'll strip out all the extra punctuation. And finally, we'll break up what's left into individual words, or tokens, so we can look at them one by one. So here we are again, back at our starting point. Our messy but very real tweet. It's got the user handle, the link, and a whole bunch of punctuation we don't need. And boom! Just like that, the @user123 and the HTTP link are gone. They don't really tell us anything about how the person felt about the movie, so they're the first to go. See? It already looks a lot cleaner. Next up, we get rid of the punctuation. All those exclamation points, even the hashtag symbol, they're out. Now we're left with just the words that carry the actual meaning. This is a huge step in cutting down that noise we were talking about. Okay, now for a really, really important step called tokenization. We can't analyze a sentence as one big chunk. We've got to break it down into its building blocks, the words themselves, and each of these little word chunks is called a token. So what happens is we go from one long piece of text to a nice, neat list of individual words. This format is absolutely crucial because it lets the computer work with our text one piece at a time, which is exactly what it needs to do for all the next steps. Okay, so we've done the first pass. We've thrown out the clutter. Now it's time to get a little more organized. This phase is all about making sure everything is consistent and standardized. First on the list, we deal with stop words. These are the super common words that kind of act like the glue in our sentences. Words like the, it, and was. They're really important for grammar, but for a computer trying to find the core meaning, not so much. Getting rid of them helps us focus on the words that actually matter. So let's apply that to our list of tokens from the tweet. We'll take out words like the, it, was, and you. Now look at what we're left with. The really important words, the ones that carry all the emotion and meaning, are starting to pop right out. Next, we've got to deal with the fact that words come in different flavors. The computer still thinks love and loved are totally different things. We fix this with something called normalization. You've got two main ways to do it. Stemming is kind of a quick and dirty approach. It just chops the ends off words. Lemmatization is the smarter cousin. It actually uses a dictionary to find the root word. It's a classic choice you have to make. Do you want speed or do you want accuracy? So, after we switch everything to lowercase and apply that smarter lemmatization to our list, loved becomes love. And there you have it. A clean, consistent, standardized list of words. Our little text office is officially tidy. We're ready for the final step. But wait, remember that big problem we talked about? Computers don't speak our language. This tidy list of words is, well, it's still just words. Now we have to perform the final and kinda magical step, translating our words into the language of math. This whole process is called feature extraction, or you'll often hear it called vectorization. This is the secret sauce. It's how we take our clean little list of words and turn it into a string of numbers, a vector, that an algorithm can finally understand and learn from. Now, one of the most popular ways to do this is a model called bag of words. And the idea is just brilliantly simple. You basically imagine taking all your cleaned up words, throwing them into a big bag, and then you just count how many times each word shows up. You totally ignore grammar, word order, all of it. Here's a perfect, simple example. If you have the sentences, Mary likes movies, John likes movies too. The model just counts. Likes appears twice, movies appears twice, and the rest just appear once. And just like that, text has become numbers, it's ready for the machine.
Okay, so we've gone on quite a journey here, right? From a messy tweet all the way to a clean list of numbers. It was a lot of tidying and organizing, but what's the point? Why does all this matter so much?
Well, the payoff is massive. Having that tidy office means you get way more accurate results from your models. When you clear out all the noise, the algorithm can actually find the real signal. It's also way more efficient. It saves a ton of time and computer power. But most importantly, it unlocks all the cool stuff, like figuring out if that tweet was positive or negative, or finding the main topics across thousands of documents automatically.
So by cleaning, sorting, and translating our own language, we've turned something a computer sees as random noise into structured, meaningful data. We've prepared it to be understood. And that leaves us with the most exciting question of all. Now that the computer can finally understand what we're saying, what secrets are we going to ask it to reveal?